Good afternoon, everybody. In Nigeria, we say testing, testing, mic testing, testing. So I just want to make sure that everybody can hear me. I know it's after lunch. We've all eaten. The room is a bit warmer than it was earlier in the day, so I hope I'll be able to get your attention for the entire duration of my presentation. First of all, I'd like to say it's so good to have the MikroTik mom back in Lagos, back in Nigeria, first time in Lagos. The first edition was done in Abuja, and I remember myself and Raphael Ajali, he's Nigerian, but he's based in Liberia. Both of us were muting this idea of having the mom back in Nigeria with Yanis Yankovsky in the Dallas mom. That was last year. And kudos to you guys for actually making this happen. Okay, so welcome back, 10 years on. That's my theme for this presentation. Okay, the title of my presentation is Quality of Service and Bandwidth Management in RouterOS version 6. About me, I'm an electrical electronics engineer. I graduated from the University of Ibadan in Nigeria. I worked briefly as a systems analyst with Procter & Gamble, also in Ibadan, before I moved into the oil and gas industry. I worked in Schlumberger in several countries around Africa, Southern, Western, and Northern Africa, before I came back to Nigeria. I was doing basically what you call cultivating services. Sorry, I didn't put up the picture for you guys to actually have a visual perspective. Okay, personally, I'm passionate about IT and telecoms. I used to do VSAT installer partner with Tidy Network AS. Tidy was bought over by Vizada, who was bought over by Astrum. I used to do that as a hobby. I was rotating out of work. I come back home. I'm 4 or 5 weeks at home, nothing to do. I just do that to keep myself occupied. I love MikroTik OS to bits. It's a fantastic operating system. I've been using it since the version 2.9, and currently I'm certified in MTCNA, MTCRE, MTCINE, and I'm a certified trainer. My guy is sitting in the crowd here. Okay, so the agenda for today's presentation. First of all, we'll define what quality of service is. We'll look at bandwidth management as well, highlight the benefits of both. We'll discuss the implementation tools for both of them and examine RouterOS screenshots on Winbox, implementation examples, and then we'll go through a summary and conclusion. We're not going to do a live demo. So basically, this is a structured overview of bandwidth management and quality of service, QoS. It gives you an insight of the tools that you can use to be able to execute quality of experience for your clients. So the first question, what is quality of service? QoS refers to traffic prioritization and resource reservation control mechanisms. It's a way by which you have the ability to provide different priorities to different applications or users or data flows in a network. Most importantly, it's an avenue for you to guarantee a certain level of performance to a data flow in a network. The key objective is quite straightforward. Anybody can deploy internet services, right? But the ability to be able to identify what affects overall satisfaction of the client is quite important. Also, the ability to capture traffic usage patterns and customize the router to dynamically work for them, for you, for everybody. Not the situation where you're firefighting all the time. Anytime your client calls or anytime the client has a problem, you're physically trying to do something. But in this case, you're looking at a way where the router is actually doing most of the work for you based on the skills and the knowledge you have and the information you're putting it for it to do for you. So, for me, I say the key objective of QoS is service differentiation. Bandwidth management. That's the process of measuring and controlling the communications, traffic, packets on a network link. The objective is to avoid filling the link to the capacity or overfilling the link. When the link is full, when it's congested, everybody complains and says that the link is slow, and it becomes a finger-pointing exercise. So if it's not properly done well, that's bandwidth management, it can result in network congestion, like I said, and of course poor performance, which leads to a very dissatisfied customer and a frustrating thing for the ISP. So the key benefit to ISPs, first and foremost, is to make money. So you want to make money, and how do you make money? Your internet traffic is one of your highest costs, and it's one of your most precious assets in the business. You want to make sure that you protect that asset, and then you deliver that asset to your clients so that it can bring you some sizable amount of return on investment. So it gives you the intangible yet significant benefit of seeing what internet traffic is flowing through your network. That's one of the best attributes I've seen working with RouterOS. It allows ISPs to tier their services to guarantee particular QoSs. You understand? You can determine what and how you deliver your services to your clients based on their needs, based on what they do, based on the kind of way that will give them that quality of experience. And of course, it reduces costs and increases the menu of products you can offer to your client. And what is the benefit to the enterprise or end user? Save money. So that's the win-win relationship in business providing services to the customer. For enterprises, you have applications that are centrally located in the headquarters, and you need the connections from remote to get into those servers. So basically, you want to ensure that business-oriented traffic is prioritized over the link that you have, so that people that are doing non-business essential work are not unnecessarily clogging up the network and frustrating the whole process. A good means for companies to avoid purchasing additional bandwidth while properly managing existing resources. It's a typical place or common place where your client calls you up and says, hey, the network is slow, and the response is increase the services. Thank you very much. Buy more. So we all know that money is one of the scarcest resources around. So bandwidth management in RouterOS, we look at it, is one of the most advanced and easy to configure operating systems for the process. There are two types basically. We look at traffic shaping or rate limiting, and then there's also the traffic equalizing or rate scheduler. Most of what we're going to look at in this presentation is going to concentrate on the above, traffic shaping. Just to illustrate, the rate limiter or traffic shaper, you can see the screen on the right-hand side. On the top side, you see the packets that are flowing over the network. It approaches about 200, I mean, just less than 200 packets are coming in. And for the rate limiter, it has no queue size. Okay, so assuming that the max limit is set to 100, the packets, anything above 100 is copped off and dropped, and this results in lower latency for the network. On the flip side, the rate scheduler, the same scenario, similar packets coming in, assuming that the same max limit of 100, here the queue size is unlimited. So what the scheduler does is that it tries to delay packets that doesn't cut off the packet. So it delays the packet and tries to send it when there's available space to send. This results in higher latency, and I think the most recommended practice these days is on the rate limiter. So this is an illustration of bandwidth and without QoS. On the first side, you see the blue is for video streaming as an example. The red, general use, browsing, etc., and online gaming. In this application, you're probably thinking, or you're probably designing for streaming and online to have highest priority. But as you can see, the red, once it enters that pipe, it is occupying most of the traffic or of the bandwidth, and then it makes the experience of online gaming, video streaming very frustrating. But with the application of QoS, you can actually prioritize the pipe, make sure that the video streaming gets a certain dedicated amount of bandwidth, the browsing with the least priority, and of course the online gaming. For businesses, you can actually do the same thing. This is just an illustration. It's just like the traffic situation. No matter how wide some roads are constructed, if you don't have good traffic management on the road, you'll always be congested. So, the fundamental concept we need to look at when we are to control traffic is we need to understand the fact that when traffic hits an interface, we don't have control over how much traffic is hitting that interface. I don't know how many of you understand what I'm saying. But basically, when it hits you at the interface, it has hit you already. There's nothing you can do about it. So, traffic control can only be done as the traffic is leaving that same interface. So, therefore, all traffic control is done on the outbound interface, irrespective if it's on the upload side or on the download side. I'll do an illustration for you to see. Assume that's the interface in green. You have the inbound traffic coming in, hitting the traffic, hitting the interface. There's nothing you can do. You have no control. The outbound is actually where you have full control. So all the rules, all the matches that you're going to put in place and the actions that will be executed against those matches have to take that into consideration. Remember, this is the same interface. Okay, so these are the tools that we're going to be looking at for implementing bandwidth management and QoS. We have the packet flow diagram, Mango, address list, simple queues, hierarchical token bucket, HTB, queue trees, and per connection queue, PCQ. This, the first one, the packet flow diagram, is the fundamental requirement in understanding what actually goes on in a router device manufactured or running RouterOS. Okay? So it was created to form a basis of understanding how packets flow through the MikroTik router. MikroTik router can be hardware from MikroTik or any other system that runs the operating system. It's used to determine where, when, and what actions can be taken at any given point. You use your matchers and strike some actions that need to be taken against the decisions. A very deep knowledge helps to simplify complicated tasks within the whole RouterOS facilities. I'm sure most of you are familiar with this diagram. It's not as legible, but this is the packet flow diagram. You can find it on the wiki online, and this is the official one published by MikroTik. Key things you need to look at is the physical in interface, the physical out interface. Then you have some decisions that are made, either bridging, MPLS, routing, or even the local process. And you also have logical in interface and logical out interface. I'm not going to go through this now because I think a full presentation is actually required to understand exactly what is going on in the packet flow diagram. But I'd like to break it down into simpler or simplified block diagrams, basically. So this is the same diagram, but in a simplified format. Just looking at block diagrams this time around. And the key things you want to see are the pre-existing chains that exist within your RouterOS. There are 5 of them. You have the pre-routing chain, the input chain, the forward chain, the output chain, and the post-routing chain. And of course, you have your input interface, the output interface, and everything local processed within the router. Now, a lot of confusion comes into play when people ask you, especially when we had RouterOS version 5. What's the input? What is forwarding? The forwarding is also going into the router. What is the input? How do you differentiate between these flows? So basically, I would say that there are 3 main flows that we need to watch out for when we are trying to interpret how packets flow through a router. The first one is the input traffic. The PFD is the packet flow diagram, which is what we've just seen. The input chain or the input traffic is anything that is coming from outside the router, entering an interface, and going to a local process within the router. So if you're telnetting a router, if you're winboxing a router, if you're SSHing a router, if you're pinging a router, it is the router itself that is responding to such requests. So that's what you actually use the input chain or the input to a router is. The next is the output. The output traffic, again, similar to the input, but the converse. The output traffic is whatever the router itself generates and sends out of one of its interface. I think a typical example is when you're doing, I would say when you're doing proxy, for example, when you're doing proxy, the destination is actually your router that actually translates. And when you're even doing reverse translation of, DNS is still input. But when your router is actually sending out something to an outward bound traffic, that's the output chain. It's not coming from a device behind the router. It's actually coming from within the router. And of course, the final one, the third one, is the forward traffic. So literally we say that this is anything that passes from one interface of the router and leaves through another interface of the router. Basic web browsing is a very good example. You're just passing through the router. Of course, some decisions will be taken while the traffic is flowing through the router, but what you're dealing with is the forward chain. I hope it's clear. And of course, there are some roles that the pre-routing and the post-routing chains play based on some routing decisions that take place before and after the forward chain. So, diagram, we're going to blow it open a little bit more. And we move from this simple to something slightly more clustered, but still very simple to understand. So basically we look at each of those chains and look at what facilities you have within them. First, the pre-routing. When the in-interface, when packet comes into the interface, you have connection tracking, you have your mangle, you have destination NAT. The input chain also has like 4 facilities within it. The output chain as well has facilities, the post-routing has, as well as the forward chain. Like I said, this is a whole subject on its own. It's a full day presentation to actually understand what is going on here. So I'm just using this to drive home my point and illustrate the subject that I'm talking about today. So you're going to see a lot of this as we go along. I'd like to bring up this topic, Distributed Denial of Service, DDoS. I'm sure a lot of us know what that is all about. The version 6 of RouterOS came up about 2013, so it's about going to 5 years now, and it's quite matured. But from that previous diagram, what happened and what was the complaint? You know, MikroTik is a company that listens to feedback a lot, and a lot of people were giving them feedback. And they discovered that DDoS attacks were always occurring on the router. You know, and it's a scenario where multiple systems are flooding, you know, an interface, a resource, especially ones that have public IP addresses. You know, they just keep targeting that system, purposely sometimes to bring it down, sometimes competition, sometimes revenge from somebody that's angry with a company. It could be anything. And this incoming traffic becomes very, very disruptive. And it's very difficult to actually pinpoint what is going on because it's coming with multiple IP addresses, and you cannot exactly detect and start using your ingress filtering capabilities to try and stop it. The biggest drawback is the fact that, if you remember what we saw just now, immediately you enter the router, the first thing you hit was the connection tracking. Connection tracking is a very, very big CPU intensive process, and once those amount of packets hit that interface and engages your connection tracking, your CPU load can rise up to about 100%, and you experience things like router freezing. You know, it's part of your QoS. Your network goes down. Or there's a customer down somewhere in your network, you have public IP address, no firewall, no rules to protect them, and they keep getting flooded, and they cannot utilize the link, and they start complaining. So basically, we look at this diagram again, and we didn't notice there was something missing. Can anybody tell me what was missing from this diagram? Anybody in the crowd? No trainers or instructors allowed? Okay? Nobody? I'll go on. So those 2 circles actually indicate that, yes, from the input, the first thing you hit is the connection tracking. but it could be optimized. In come tables. So the raw tables came in to mitigate and solve this problem of your router connection tracking flooded by DDoS attack. And with that, to date, I think this was done sometime this year. With that till date, it has actually reduced the impact of having DDoS freezing the router. So what do you do with the raw table? It's a very, very useful tool for DDoS attack mitigation. It allows you to selectively bypass or drop packets before connection tracking. So once that happens, you still have access to your router, but CPU load is still very low, and your router is not freezing. Again, this is mostly for attacks at the router, right? And like we said, it doesn't have matches that depend on connection tracking, and it just works. Okay, so this is where you find your route table in Winbox, IP, firewall, raw, then you click the new button, and then you create the chains. There are two chains from the diagram we saw. It's on the pre-routing and the output chains. Okay? So, now we go back on track. Connection tracking. It's actually the way for you to see what connections are making their way to, from, and through the router. Those were the three illustrations I showed you earlier, talking about input, output, forward chain. So connection tracking, when it is enabled, most times it's set to auto, but when it's enabled, it actually gives you a picture of all the connections that are going through it. It's required for several firewall facilities in the router function. The NAT, the mangle, the filter, will stop working if disabled, if connection tracking is disabled. And what does this show you? It shows you the source and destination IP addresses and the ports associated with a specific connection. Again, reiterating, it's CPU intensive. So this is where it actually takes place. Connection tracking. It's in two places, the pre-routing and the output chains. And then to find it in the Winbox, you go to your IP firewall and check connections, and you see all the connections displayed. Mango. The Mango tool marks IPs, connections, bidirectionally, and packets unidirectionally with special marks. You need to know this. Connection marks are bidirectional. The packet marks are unidirectional. And these marks are used for future processing only within the same router. So if you have a chain of routers in a network, your Mango rules will only work within a single router. You have to do, similar operations in other routers within your network. Okay. It is used to modify some fields in the IP headers, like these DSCP, TOS, TTL, MSS fields. Quite clearly, the Mango is happening in all the 5 chains, and you can create your own custom user-defined chains. I'll highlight them again. In all the chains, all the 5 chains, you can see where the Mango occurs. So you can actually identify packets, identify connections, and mark them to eventually take decisions with other facilities. On Winbox, so you go to IP address, again firewall, Mango, you click on the new button, you choose the chain of interest, and then you select your matches, and then you choose the action that needs to be done against those matches. IP address list allows to create actions for multiple IPs at once. So if you have a bunch of IPs that have similar actions that needs to be taken, you can use an IP address list to consolidate those actions together. It's possible to do it manually. It's possible to do it automatically. Basically, if an IP address can be added to the address list permanently or for a predefined period of time, you can do a temporary or permanent one. And of course, the IP address can contain, like I said, one IP address, an IP address range, or a whole subnet. Similar direction, IP firewall address list. And if you want to do it manually, you click the new. If you've set up some rules to dynamically add addresses to this list, you'll see them displayed over here. So, we're getting closer. The queues. What are queues? Queues are used to limit data rates for IP addresses, subnets, protocols, ports, interfaces, and other parameters. You prioritize some packets flows over others to create efficiency. You configure burst traffic for faster browsing, very important for a very good user experience. And then you share available traffic among users equally, depending on the load. That's also possible. And then you can limit peer-to-peer traffic. Queue properties. You have 5 displayed here. The limit at, or the committed information rate. The max limit, or the maximum information rate. The burst threshold, the burst limit, and burst time. Again, this topic is, or this subject is, can form the basis of a presentation on its own, explaining how these terminologies work, but you need to have an idea of how to put all this together to have a good QoS implementation. Queue properties. The parent queue, priority, packet max, queue type, and bucket size. These also play their significant roles, and they're very useful, especially when you are doing things like HTB, which will still be explained further down the line. So let's look at simple queues. The simple queues, as the name suggests, is the simplest way to limit data rates for specific IP addresses, interfaces, or subnets. You can download, you can limit their upload speed, you can limit their total speed independently. In the new version now, you can do it independently. In version 5, you couldn't do it independently. All rules are processed sequentially from top to bottom. So basically, you have queues. Maybe you have 20 queues, right? The top queue processed before the second, before the 5th, before the 10th, before the 20th. I've seen scenarios where people have 20 simple queues. They put 1 meg on each of these queues, and then they have 10 meg in that circuit. Honestly speaking, if 10 people are active on the network, the 11th all the way down to 20th will get nothing. So that's how simple queues work. So you need to watch out for that. The fast track rule in firewall filter needs to be disabled for simple queues to work. Okay? So the simple queues on RouterOS version 6 is not as simple, it's not for simple tasks anymore. Traffic identified are based on source address, interface, destination, hence no need to do packet marking. There's no packet marking taking place here. The fast hash algorithm, especially on multi-core hardware, is utilized. The number of simple queues is no more relevant. In version 5, it used to be a big concern because the global HTB was happening in the pre-routing chain, and pre-routing, post-routing, you had double the simple queues were being executed twice, becoming CPU intensive. Now that is no longer happening. You can have thousands of simple queues without heavily loading your CPU. And of course, they can be created dynamically or by scripting as well. Okay, we've mentioned this before. Fast track in firewall needs to be disabled to work. The two spots where simple queues are executed immediately after the global HTB in the inputs and the post-routing chains. So if you have traffic coming in and going through the forward chain and leaving the output, you can mangle in forward and then apply your simple queues, and your bandwidth management or QoS will work. In Winbox, you go to queues, simple queues, hit the new button, you put in your parameters, the properties we saw, the burst limit, burst threshold, burst time, max limit, per direction, and you get the result that you have planned to get. You have to make sure you enter the target. The target is very important. HTB. This is classful queuing method that is useful for handling different kinds of traffic. Okay? It allows to create a hierarchical queue structure. So it determines relationships between queues like parent, child, child, etc. And it's very useful for priority bursts possibilities within the network. So the bandwidth management implementation in RouterOS is mostly based on HTB, which was the rate limiter that we saw earlier. 3 basic steps required. You match and mark traffic, create rules and policies to mark the traffic, and then you attach policies to specific interfaces. So this is a typical HTB diagram. You have A being the top parent queue, and it has 3 direct child queues, the B, the C, and the I. The B itself has 2 child queues, and C has 3 child queues. But it's very interesting to note that the names, first of all, the naming nomenclature, A, B, C are parent queues, B and C are parent queues and also child queues. These are called the inner queues. And then at the bottom of it is where you have the leaf queues. Okay? I'll explain what happens there. At the queues or the inner queues, only max limit works at these levels. Only max limit work at these levels. While at the leaf queue, that is where the limit at and the priority actually takes place. So if you are limiting, if you engage limit at rules and then you apply priority and you do it in the inner leaf or inner queues, you get no result. It won't work. Okay? So this is the execution of that diagram. You can see it in the HTB. HTB is executed in queue trees, basically. So you can see A is the parent, and then you have B and C are the child, and then the sub-children are also there. So D, E, F, G, H, I are the leaf. Looking at it this way can be complicated. It's always very good to draw your diagram, the way it was in the previous slide. So, caution on HTB configuration. You need to be very careful when you're configuring. The limit at and priority will not work if there's no parents in the hierarchy. So it will only work if there's a parent in the hierarchy. So people sometimes, they do queue trees and then they place all the queues in the tree, but there's no parent. They don't assign parents, they don't assign child. you don't get a very good result. It doesn't work. Also, like I said earlier, limit out and priority happen at the leaf queues. So queue trees, which is the implementation of HTB, is unidirectional in nature. It is one of the queues of HTBs, requires 2 rules per full duplex traffic control, unlike simple queues where you can use just one queue to set both direction. In queue tree, for the upload, you need one queue tree, you need one rule. For the download, you need a second rule. Okay? Now, the big advantage is that all rules are processed simultaneously, which is highly efficient for the CPU. It's not like the previous one. Execution happens at once. Parent, priority, and packet marks are very important for efficient operation. I can't say that again. Okay, so this is where the queue tree actually happens in both the input and the routing chains. And of course, the Winbox screenshot, you go to your queues, your queue tree, new queue, you enter the parameters you require to get going. PC queue, per connection queue. So, the queue type for optimizing large QoS deployments by limiting per substream. Substitute multiple queues with one. So you can have multiple queues, and then basically what the PC queue does is that it turns it into one queue for you, using flow identifiers to differentiate traffic. Several classifiers can be used: source address, IP address, source port, destination port. This is basically a diagram of flows. The flows are coming in, flows 1, 2, 3, 4. The PC queue classifies source address, and then the sources are formed, and then the round-robin algorithm takes care of the whole business. PC queue classification example here, you have about 18 stream flow of traffic coming in. The PC queue classifies the source address. It classifies the source addresses into 3 substreams. The other one, by destination address, into 3 substreams. Basically the same thing is happening here, but the classification is by destination port and destination address. Okay? So this is PC queue in action. You have to set, in this scenario, you set PC queue rate to 128 kilobytes. And the max limit is 500. Yep. If you have 2 users, they will use 50% of the network. Just one user, you use 25% of the network. If you have 4 users, they consume everything and they share the bandwidth equally. If you have 8 users, they split all the bandwidth equally as well. And in this scenario, the PC queue rate is set to 0. I think this is the best scenario to use. You set the PC queue rate to 0, and with the same max limit, if you have 1 user, he has the opportunity to occupy the whole bandwidth, 100% of the bandwidth. If a second user comes in, they split the traffic into 2, and both of them use the traffic. Same as if you have 4 users, they split the traffic evenly into 4 and then 8 users. Okay? Where to find it on Winbox? You go to queues, queue type, news. You see the PC queue parameters. Okay? Again, the caution and things to note. PC queue takes its data from connection tracking. If both limits, PC queue rate and max limit, are unspecified, the queuing behavior will be imprecise. So at least you need to specify one of the 2. Okay? So in practical terms, you can actually use simple queues and queue tree in combo. Very advisable, because like we said, a major aspect of QoS is traffic prioritization. A major aspect of bandwidth management is client limitation. So you can prioritize traffic using the forward mangle, as mentioned earlier, and then you use the queue tree to set the rules, and then you can set the limitation with simple queues by targeting the specific IP addresses of the client. You use the two in combination, it works perfectly. Finally, we come to a summary of what we've gone through on my slides today. We've looked at the use of mangle, address lists, simple queues, and queue trees. You know, packet mark by traffic can be done on the mangle chain. You classify clients by IP address in address lists. You prioritize and limit by type in the global HTB. You limit traffic per user in simple queues. And of course, you utilize PCQ to ensure a good quality of experience. Okay, that draws my presentation to a close. The conclusion is that MikroTik RouterOS is one of the most advanced, easy to use, and engaging bandwidth management and QoS tool out there in the market. Understanding the packet flow diagram is what will set the ball rolling for you if you really want to understand this part. And a knowledgeable combination of the right tools will bring about the desired results. Of course, I cannot complete this presentation without a couple of acknowledgements. I think this presentation would not have been possible without the vision behind TikTube. So I say thank you to MikroTik and the Latvia Q. You guys have been doing a wonderful job. And of course, please, I implore or ask and seek that you kindly change your YouTube channel to TikTube. We love that name. Don't let that name die. And somebody that I would like to recognize is Mr. Valence Riadi. I call him the king of QoS. Basically, almost all his presentations in the MOMS are on the subject of QoS. He has several related videos and PDF presentation slides online. And basically, I crown him as the king of QoS. Thank you very much. Even his presentations in Indonesia, I watch them because you can actually follow the flow based on the simplicity he puts in his presentations. Thank you very much. And questions? Okay.